Assalamualaikum, and my name is Qhilfi Qhaizuran bin Sharizan from N3 AT2402B. Student ID 2025221634, and today I will present about fruit and seed development for AGR 499. First of all, I will introduce you about fruits. Fruit grows from a matured ovary. Its original function is to protect the seeds inside and helps in seeds deposited by animal. There is also a seedless fruit which is formed by parthenocarpy by other means is absent of fertilization. Next is fruit type. So fruit has 4 different types, which is simple fruits, aggregate fruits, multiple fruits, and accessory fruits. So for simple fruits, fruit that develop from an ovary of a flower. For aggregate fruits, fruit that develop from multiple of carpels of a single flower, consists of many fruit that clustered together. Next is multiple fruits, a fruit formed by the fusion of many flowers, ovaries, growing close together into one large fruit. And the last one is accessory fruits, fruit that is developed by other plant parts but ovary, may be simple, aggregate, or multiple fruits. Example for simple fruit is peaches and beans. An example for aggregate fruits is raspberry and strawberry. Example for multiple fruits is pineapple and jackfruit. And lastly, example for accessory fruit is apple and pear. And now let's move on to seeds. A seed contains all of the genetic information needed to develop into an entire plant. A seed is a matured ovule containing an embryo, storage reserve tissue, and a protective outer covering. Seeds are the sexual reproductive unit in the plant. And now let's move on to seed structure. As you know, the seeds consist 3 different main parts, which is endosperm, seed coat, and embryo. In embryo, you can see there is plumule, epicotyl, hypocotyl, radicle, and cotyledons. So, in seed components, there is endosperm functioning as food supply for seedlings, seed coat, which is an outer layer of seeds that protect them from pests and disease. And third is cotyledon, specialized seed leaf. And number 4 is epicotyl, tiny shoot for the whole developed plant shoot system. And then we have hypocotyl, germinating seedling stem which can be found underneath seed leaf but above roots. Then we have radicle, primary root for seedlings. And lastly, we have plumule, shoot system for plant. And now let's move on to seed development. Seed development contains 3 stages, which is histodifferentiation, cell expansion, and maturation drying. Let's move on to stage 1, which is histodifferentiation. What happened here is rapid increase in seed size, mostly due to cell division, not cell enlargement. The embryo and major seed tissues begin forming and specializing. Next is cell enlargement, which is a stage 2 for seed development. This is the largest growth phase. Cell enlarge and the seed fills with food reserve. Then most of the seed mass is accumulated here. And the last stage is maturation drying, which is a stage 3. Seeds dries out dramatically. Fresh weed drop because water is lost. The seed become dormant and ready for dispersal. And now let me interpret everything from this graph. So what is in the graph is, from the histodifferentiation, we can see the dry weight start to increase slightly. Then the fresh weight, mostly water at first, also begin rising slowly. So in the cell expansion, which is stage 2, the fresh weight orange line increase the most. Then the water content, the green line, is also high. Then the dry weight, the blue line, climbs steadily as nutrient are stored. And for the stage 3, the maturation drying, we can see that the water wave decreased sharply. The fresh wave drops too, and finally, dry wave remains steady or increase slightly as a final reserve accumulate. To summarize everything, the fresh wave rises in stage 1 and 2, then drops in stage 3. Then, the water wave peaks earlier and then drops the fastest during maturation. And finally, the dry wave steadily increases as the seed fills with nutrients. And finally, let's move on to seed germination type. There is two types of seed germination, which is epigel and hypogel. Epigel germination, the cotyledons are pushed above the soil. The seedlings hypocotyl elongate and lift the cotyledons up. Cotyledons usually become green and photosynthetic. And finally is hypogel germination. The cotyledon stays underground. The epicotyl elongates, pushing only the plumule above the soil. Cotyledons act mainly as food storage, not for photosynthesis. And now I will show you the demonstration of epigel and hypogel germination. That brings me to the end of my presentations. Thank you for your time and attention. I hope the information I shared was clear and helpful. Thank you.